Oh, hi students, this is Dr. Dong. Today we're going to talk about the first main topic in our class, which it is system call. So from last week we just had a very soft start, and the main topic of last week is what is an operating system. So if you can remember, operating system, I said that basically operating system is a program that coordinates our hardware to execute the softwares. And so the most important metric to evaluate an operating system is just the convenience and the efficiency. Also last time we said that operating systems provide low-level instructions for the programmers to control the hardware. This is the and th this is especially more important for Linux or Unix-like systems. And today we're going to learn what are these low-level instructions. And also, last week I said the only task for you is to obtain the access to a Unix-like system. So if you have a Mac, that's absolutely fine. If you don't, you need to install Linux Ubuntu, which is the version of Unix-like system that is most close to Windows. And so today we're going to use that, okay? So this is the outline of today's lecture. First, we're going to go over a little bit about computer architectures because I don't think most of you have that background. But as you probably know, that operating system is like just stands in between the hardware and softwares. We are pretty familiar with the softwares like the web browsers, like the video games, but for hardwares, not all of you have the background. Okay, so that's why I need to talk a little bit about that. So that when we introduce the details of operating systems, it's easier for you to understand it. And after that, I'm going to talk about the structures and the structure and operations of operating systems. And also, I'm going to talk about some components. And at last, I'm going to introduce some practical commands for you to execute on Linux-like systems. Let's first recall this diagram, which we learned last week. So from this figure, we can see that the bottom layer of our so I'm going to use this. Okay, the bottom layer of our computer is just the hardware, which consists of the CPU, graphical card, or the motherboard, and also the RAM. Okay, and so on the top layer, it is the softwares that we want to execute, and then what stands in between the blue part are all operating systems. But inside operating systems, we can just divide it into 3 different layers. The first layers are called services or kernels. These are the very essential program that help us to control program execution, control the I/O operations, and to help us to manage the file systems, and also network connections, also security, etc., etc. Okay, and then so on top of that, okay, on top of that is the top layer. The top layer in our operating system is the user interfaces. So if you use Linux, if you use Ubuntu or use Mac, you will have access to some graphical user interfaces. For example, if you use Mac, this is the user interface that it shows to you, and but if you don't use Ubuntu or Mac, say for example, if you use FreeBSD or you use SE Linux, so the kind of user interface that you use most is the command line, which is called the terminal. So to access to terminal, okay, no matter if you use Linux or Ubuntu or Mac, you just need to go here, need to search for terminal, and it will be here. It is something like this one. Okay, so for my terminal, this terminal is totally black, but I can just show it in a better color. Let me say I just go to the basic one. So go to a white color and black background, and so this is more friendly. So here you just execute, you just type in your commands and it executed. So and then so in between them are just the system calls. So here still it is still very abstract for you. What are system calls? But we're going to explain that in about 5 minutes. Okay, so okay, from the first lecture we know that the operating systems provides the fundamental low-level instructions for the control for the programmers to control the hardware, and so here okay, let's keep this sentence for a while and let's come back here. Let's come back to this part called kernel. Okay, so what is a kernel? So what is the kernel? So the kernel of an operating system. So if you Google it, you probably can find a very long definition of that. So it's a computer program that constitutes central core of a computer's operating system. It has the complete control over everything that occurs in the system, so which includes like input and output. Like also it controls the CPU allocation and also manage the memory, etc., etc. So the definition is pretty long. But from the definition, what you can tell is that okay, the system kernel is the central part, it's the core of a computer operating system. So it has control over everything. So, but in one short sentence, we can say that system kernel is basically a program, a computer program that needs to be run at all times on the computer, and it helps us to do. It provides a lot of services for us, like program execution, input and output operations. Most of the time, we just don't feel the existence of the system kernel because you just take it for granted. Say once if you run, if you want to execute a program, just double click it and it runs. So you just take everything as granted. But actually, all of these services are provided by system kernel. So it is the essential part or the core of our operating system. So, and what about a system call? Actually, so if this is the kernel that we have, which provides all the services for us, then system call is kind of like the program interface provided by the kernel. So it's like it's something like the kernel provides some functions for us to call or utilities for us to call. It's more like the programming interface or library provided by kernel. So again, this may seem like very abstract for you, but let me just give you an example. Okay, so I think most of you have the experience of programming in Java, right? So if you use Java, and probably you need to go to check one thing that is called Java API. Not PI, it's Java API. So Java API, from Java API, you will be able to find, okay, there's programming interfaces or these functions provided by Java. Let's go to one of them, utilities. So in utilities, let's just go to the most important data structure or the most frequently used data structure provided by Java, which is the array list. So this is the programming interface provided by Java, and you can call. So Java already implements these functions like this class. So it provides constructors, and also it provides some other functions. And so you can just call them. By calling them, you just you're just invoking the implementation provided by Java. So your life will be easier. So it's like you are going to program based on implement your program based on the Java library. Okay, so this is the user interface provided by Java, or the user interface is provided by Java library. Okay, you can you can pretty much take so there are some libraries come with Java. Okay, and here system call is like the program interface for our kernel. Okay, so here you can just replace kernel with Java virtual machine, and then the system call interface as the Java API. Okay, so so let me give you a different example in C++, because here we are dealing with operating systems. Most operating systems are programmed in the language of C for the purpose of efficiency. So in this method, we're going to go over some C code and C programs, but I'm going to explain them for you. Compared with Java, it's more difficult to understand and program in C. That's for sure. But I'm not going to require you to program in C. I just want to explain the code to you. So so here are just two different pieces of code that I implemented before. So let me just go to the code. Okay. So documentation, graduate, and then slides, and then we have week 1. So in week 1 we have the code. Okay, so here I'm going to open some code like file io leave.h. So here this is the header file of so which declares the function that I want to implement. So for example, here I have so I declare that I want to implement a function whose name is open file, and here you can just, so from the name you can probably tell the main utility of this function is just to open a file, giving the path of that file. And then append file is like I'm going to append a string. Sorry. I'm going to open a file and append a line and type a line and append that line into the file. So here, let me just show you the actual implementation of the code. So file, yes, right over here on the, so now on the left it is the CPP code. CPP code is actually the implementation of these declarations. So for example, here if we go to the append file function, so here first it just opens a file, and then so with this command, so cout enter a new line. If you are familiar with Java, cout is pretty much like system.out.println. Sorry, it's cout with endl over here is the combination of them is like system.out.println. So this is like first it will print a line saying that enter a new line, and after that I have cin. Cin is like so system.in. Sorry, I don't remember what is the input function for Java, but so from this you can just type in a line, and this line will be entered into a variable called line, whose type is string, and then it will append this file to the end of the file. Sorry, it will append this string to the file that has already been opened. Okay, so these are the operations, and here you probably can see these operators. These are called the stream redirection operators, and these are provided by C. Okay, so here if we go to C++ reference, so you will be able to find them. Okay. Let's just open once, wait 1 second. Then if we go to input and output, and then we have this, let's just go to IOStream. So as you can see here, we have this cin, the cin so function provided, and then we also have, let me say what's next. Also we will have the iStream. So let me go to iStream. Let's go to the iStream package. So in the iStream package, we will be able to say the operator. So it defines the operator. So this operator, so this is like the program interface provided by C++, the library of C++, and you can just call this function and invoke the basic implementation. So here it gives you some example. Okay, so as what we see before, it has cout, enter a number, and then use cinto it to allow the user to type in the number and store it in the integer n. Okay, so here let's see what does this function do. So first let me make clean, and then let's make, so make is like I just want to compile the file into the executable format, and here you should be able to see a file in the red color. That is the executable file. So here we're just going to execute. So it says, okay, file IO test, welcome to the class. Sorry, that's the function. Yeah. Oh, let me say file IO test. No, let me go to the main function. Okay, in the main function, what it does is that, okay, to open a file, you just open a file called aaa.text, and then you say it outputs, it print out the line test function open file end, and in the open file, let me go back to that file. In the open file implementation, what I do is that, okay, I just print out, read the file content and print out every line from the file. Okay, so this is what I do over here, and then if we go to, so in the same folder we have a file whose name is aaa.x. Let's just look at the content in aaa.x. So the content of aaa.x is welcome to the class of operating system, have a nice class. And so if we execute the file, if we execute the file IO test executable file, we'll be able to say, okay, test function open file begin, and it just print out every word in the file in that file. Okay, so this is what we do. And so here the purpose for me to introduce this piece of function is to tell you that, okay, C++, look at that, C++ provides such program interface, and these are called, this is called here the C library. Okay, this is called the C library, and the C library is based on system call, and so the implementation of these operators are just based on the system call named read. Okay, so this is provided by either the Linux systems, the kernel of Linux systems. So the implementation of these operators are just, so in the implementation of this operator, they just call the read function, which is provided by the system call. You can see that. Okay, so in terms of the hierarchy, so kernel is at the bottom, and kernel provides a program interface for us, for programmers, to call the kernel functions, some kernel functions. And then there are some libraries like C, like Java. They do some they provide their libraries based on the system call, so they're at a higher level. Okay, so in general, the higher level it is, the easier it is for the users to use, but it will not be as efficient as the lower level programming interface or library. Okay, so this is what I want to mean. And actually here you may wonder, okay, so how do I check the manual or the such API for the system for the system calls? Or so here you just need to call the function main. After you type in your open your terminal, just call the function main. Main is short for menu. It's like you want to open the menu for something, and followed by the function name. Here we just we just follow it by the name main read, and main to read. Yes. So this is the system call provided by. You can see that here it is the system call manual. Okay, so BSD system call manual. I'm using a Mac. If you remember from our last class, let me open the lecture of last class. Mac the kernel of Mac is based on FreeBSD. Okay, the kernel of Mac is based on FreeBSD, and FreeBSD is just a variation of BSD. That's why we have this. Okay, we have this saying that BSD system call, but if you use Ubuntu, it will show Linux system call rather than BSD system call. This is because Linux follows a different branch in the hierarchy of the Linux systems. Linux is right over here. It has its own kernel. Okay, so here, if you open the menu, you should be able to say, okay, this is provided by the system. This is one system call in the so it is accessible in the C library. Okay, so you can call this function by using the C programming language, and it has a function called read. So here it's just read something. It's going to be very complicated for me to explain the details of this at this time point. So I just put it aside. So here I just want to let you know what is a system call. System call, as you can see, system call is like the programming interface provided by the kernel of our operating systems. And so the system calls, there are different types of system calls based on their purpose. So for example, there are some system calls for process control. For example, fork, exit, wait. We will be able to learn the fork system call in probably 2 weeks. And then the file manipulation system call like open, read, write, and close, etc., etc. Okay, so these are the system calls. And so as I previously said, system call is just a user interface, the programming user interface. So it is so when you write a program, most likely in C, you can just invoke these system calls. You can call this invoke these system calls and directly interact with the kernel of your operating system, which is going to be extremely cool and extremely efficient, very efficient. Okay, and next, I want to introduce this. Okay, there are actually 2 modes in the operation of our operating systems. They're called user mode and kernel mode. So basically, a system call can only be the system call can only be invoked in kernel mode, while our user functions, like after you implement your Java program, the most part of the Java program is going to be executed in the user mode. So the purpose for for the designer of the operating systems to have these 2 different modes is because they want to have better security. So because these system calls are more sensitive, so you should have if you want to execute this more sensitive function, you should go to a more restricted model to make sure that you don't do like too much damage. Because there could be some adversary who just want to exploit the vulnerability of your operating system and do something bad. So here you can take this for example. Okay, so for our university, okay, if you enter our university and if you want to go to, for example, a classroom, if you want to enter a classroom, if as a student, if you swipe your card, it won't work because the universities are worried that maybe some students will take away something from the classroom. Unfortunately, I think last year or the year before last year, something like this happened. Our department lost a couple of desks and chairs. So if a faculty uses swipes his card, he or she should be able to open the classroom. So it's like by giving the card, different cards, different privileges, it's actually the university actually, you can take it as this way, the university actually functions in different modes. So the faculty mode and the student mode. Okay, so of course the faculty mode has higher privilege. So Okay, this is what I just said. In the user mode, if you call the function called printf, which is a part of the C library. Okay, so let's say we call main printf. No, main2 printf. Say main3 printf. Yes, yes, main3 printf. As you can see here, we open the manual of the printf function, and here you can see that it's not BSD system call manual. It's BSD library function manual. This is because this printf function is a part of this is the program interface provided by C. The program is provided by C rather than the kernel. So that's why it's called library function. So basically, if you open a manual, you should only be able to say either library function or system call function. So here we have the printf function, so provided by C, and then and in the implementation of these functions, of this function printf, it calls the system call called write. So here we can just go to open another tab and say command write. Say command to write. Yes, here we can see that it is system call library. Okay, so the write function is provided by our operating system as a system call. Okay, so this is what I just said. Okay, how do you tell if a command or if a programming interface is a system call or if it's provided by a library? So it's easy. You just tell it from the top. If it's a library function, it will say B library function, or if it's a system call, it will say system call over here. And so this is the dual mode that I just talked about. We have kernel mode and user mode. So the system calls can only be executed in the kernel mode with higher privilege, and this ensures the safety or the security of your computer. Okay, so now I just want to talk a little bit about the organization or hardware part. So for now, I just want to mainly focus on CPU. So nowadays, like all of us know CPU, right? We have maybe i9, i7, i5, i3, different series of CPUs, and so the difference between there are definitely difference between the CPUs. So here you may wonder, okay, what is your CPU? And actually, if you do not use a Mac, Mac wouldn't work. But if you use Ubuntu or Linux system, so you can just execute the following command to check your CPU. So I have a server which runs the Ubuntu. So let me go log into my server first. Okay, so so I tap in the wrong command, the wrong username. It's the UNGB. Yes, I'm here. So you can see that the servers. So even though I'm executing commands remotely on my server. Okay, so my server is actually located in a campus in the university hall. So you can see that the servers runs the Ubuntu. The version is 8.04. Okay, so so here so if I want to check, so if you happen to have a Ubuntu with you, can just execute the command LSHW. This is a command provided by Linux kernel, so not BSD kernel. Okay, so if this command only works on Linux systems like Ubuntu or SE Linux. If you I just typed in the wrong command. If you follow me, type in the command ls CPU, you should be able to see the CPU that you have. So the CPU that I have is a i7 7700K, and so it has 4.2 gigahertz, and it comes with 8 CPUs, and on each socket there is only one socket, while on each socket on the socket there are 4 cores. Okay, so this is the information that you can get from my my server. So, but let me show you. Okay, if you here, I'm just executing the command on my Mac. So if I use ls CPU, it doesn't work. So here, here the reason why I want to do that is because on a single computer we may have multiple CPUs. As you can so probably you know that CPU is the central processing unit. All the commands or all the programs has to be executed by them. So here my CPU comes with my server comes with 8 CPUs. So most of the time I'm just using one of them. Okay, most of the time I'm just using one of them. So it will be a waste if I just like I'm the only user to that. So then people comes with different designs so to maximize the utilization rate on a computer. So there are different ways to improve the utilization rate. The first one is called multi-programming. Multi-programming is like this: you execute multiple programs at the same time on a single computer. So say like if I execute 2 programs at the same time, then so those 2 programs will occupy 2 CPUs. So which definitely leverages more resources rather than leaving like just running. So if I just run one command, one program, then only one CPU is utilized. So the rest of 7 will be wasted for that period of time. So if I execute 8 different programs at the same time, then mostly likely all these CPUs will be used, and this is called multi-programming. And the other way to improve the utilization rate is called time sharing. Time sharing is like instead of just letting me run command right over it, so I can just give access to multiple users. So that okay, all of these users can log into this computer and execute command at the same time, and so this is called time sharing. So when we have multiple users access the resource at the same time, we say this is called time sharing. Okay, so this is these are the 2 new concepts that I need to introduce today. Multi-programming and time sharing. So next, let me say, and here, okay, a more complicated hardware structure is like this. So where we are going to have more computers interconnected, and we call them a cluster. So if you are familiar with Amazon EC2. They provide computer clusters like for the purpose of research. It's like if you have a very huge program to execute, you will want to execute it on a cluster of computers to make sure that your program can finish within maybe 2 days or 1 week. You don't have to wait like until the end of your life to see the program finish. Okay, so and to manage that kind of system hardware, so it's going to be more complicated. So the operating system for the clustered system is going to be more complicated, definitely. And so in this semester we're going to cover the 4 different aspects of our operating systems, which includes the process management. We're going to spend 4 weeks on this topic, and then 2 weeks on memory management, 1 week on file systems, probably 1 week on security if we have sufficient time. But because security is not the main topic of our class. If you are in a cybersecurity program, you are going to learn more security stuff in a computer security class. Um, so this part is optional. If we have more time than expected, then yes, I'm going to spend 1 week on this topic. If not, then we're going to stop at here, which is far more enough for you to understand the design of modern operating systems. So next, I want to introduce some commands for you to execute. Okay, so the first command I want to introduce to you is called uname. And unfortunately, uname is only accessible, is only available on Linux systems like Ubuntu. So if you have Mac, let me double check. Okay, yes, okay, sorry. It also works on Mac. So uname can tell you, okay, if we check the menu of uname over here on my Mac, you can see that uname just print the operating system name. So it has different options like -a, -m, -p, or -v. So here, if we want to know the name of the operating system, we just provide -s. If we want to know the version of the operating system, you just print out, you just use the -v version. If you want to know the release of the operating system, then you just use -r. So here we are mostly interested in the name of the operating system. Let's say, sorry, not main -s, -s, uname -s. So it's starving, and here if you use uname -a, we can see that the operating system that I'm running starving is a version of Mac OS, and the name of my computer is Core 0755, and the version I'm running is 18.6.0, and it uses the Darwin kernel. Its version is this. Okay, so here this is what you can see, and the hardware that I have is using 64 bits memory. Okay, so this is what I can get from my Mac, and let me go switch to my server, which runs Ubuntu. So if we use uname, you can see that it says Linux, and if we use this one, uname -a, let's just get everything. It runs Unix Ubuntu version 18.04. So here, let me just log into another server I have. I have a lot of servers actually. So it is another server I have. So this server runs FreeBSD. So here we can just use. Okay, so this it says it's also Linux. Actually, it's FreeBSD. Oh no, this sorry. My bad. So it actually runs Linux, not FreeBSD. I'm sorry. Okay, so I'm going to exit from there. Okay, so this is a command for you to type in from the terminal to say the version of operating system that you are running. Okay, and then this command LSHW is going to print all your hardware information. So, but it only works on Linux systems like Ubuntu or SE Linux. So here, if we check the command of LSHW, so it said this is the hardware that you have. It has way more options than we need. So let me just execute the command. Okay, so you can say that the output is quite long, but let's just focus on this this part. Okay, it says I got I got one motherboard, and so the motherboard I got 62 gigabytes memory, and the GPU that I'm running is as what I showed you before. Okay, and then these are the PCI information. So and also I got two graphic cards. Let me say, where can I find the information? Yes, it's NVIDIA. Can I find the model of it? Probably not. Nope. So, but what I can tell you is that server comes with two NVIDIA RTX 2080 Ti GPU. So let me log into the other server that I have, and if I execute LSHW, so it's even longer. And on this one, I got 4 GPUs. So you may wonder, so what's the purpose of having so many GPUs? Am I using my server to play video games? The answer is no. I'm using the GPUs to train, kind of like doing deep learning, to train something like a neural network. So let me say, this is the second server that I have is way more complicated than the first one. I just got the second one in the summer. So here it comes with a CPU, and the memory it comes with around 200 gigabytes memory, and it comes with 2 CPU and 4 GPUs. So you can take them as supercomputer, kind of like supercomputer. Okay, so then the next command that is LSCPU, which I just introduced before. And if you are running a Mac, actually you can use it in this way. You say cat block. No, it does not have it, so forget about that. Okay, so the last one, the last one is called DU. DU is to check the disk usage. So it also has a lot of different options, but if you have time, you can just go over these different options. But personally, I just use this one most of the time. It's just like it just displays the disk utility in human readable format. Okay, and also I would like to use -m because it displays everything in megabytes. Or maybe you should go for -g. It displays the size in gigabytes. So here, if we just, let me see where I am. I'm at this folder, and you can see on this folder I have the following files. So probably it should use this one. Just, okay. No. So in total, all this folder takes 404 kbytes. So let me say, okay, display. So here you can see the size of each of them. So so the size of each of them is over here. Okay, in the human readable format. Okay, so this is the end of the lecture today, and so for you, the reading task for this week is to read through from chapter 1.1 to 1.9 and chapter 2.1 to 2.4. Okay, so I'm going to talk to you next week, and have a wonderful week. Thank you.